So they give you 3/10 plus 3/100 plus 3/1000. 3/1000. So to those who are joining us for the first time, for you to recap, you can also go to my YouTube channel. The videos that I've just posted there, that will help you to remember everything that we did so that you can catch up on your spare time. So this session, basically, we are wrapping up sum to infinity, of which after I'm wrapping up sum to infinity, then I'm closing the chapter of sequences and series. But there are more videos on the YouTube if you didn't understand. But after I'm explaining this example number 1, I will go back and try to give you a recap of everything that we did so that you can have a little glimpse of what we were doing. So in maths, when they say find sum to infinity, guys, there is a formula that you must always know that denotes or that speaks about sum to infinity in maths. So that formula, it says sum to infinity. I'm writing it down here with the yellow color. It's equals to, it's a formula, right? It might be there in the formula sheet. It might not be there in the formula sheet, but I will encourage you to know it by heart. It's A over 1 minus R. So to those who are joining us, when we are saying A over 1 minus R, this formula, it's, when we are saying A over 1 minus R, this formula is a formula that we use for sum to infinity. This formula is the one that we are going to use. It's the formula that we use. You can write it for what? For sum to infinity. Sum to. There is someone who has a background noise. Okay, let me mute everyone. And then, yeah, I've muted everyone. Ne? But as long as you don't have background noise, you can unmute yourself. I don't mind. And then if you have a question, then please let me know. So this is the formula that we use for sum to infinity. So you'll always get this question in maths when you are writing. They will ask you, as in like the question here written in a green color, when they're saying find sum to infinity of the series. And then I told you that when they speak about the series, a series, it must have plus signs in between, right? So that is the formula that you use for sum to infinity. But before you can use the formula for sum to infinity, there are two components that you must have. Number 1, you must always have the first term, which is t number 1. T number 1, we all know that is equals to what? It's equals to A, and then it's already given on the question. Is there anyone who has a question? So this 3/10, it represents A. So you're going to write 3/10 here. So you don't calculate 3/10, it's given. So that is the first term. T1 simply represents term number 1 of the series, right? And then before that, you can see that the formula for sum to infinity, it has what? It has R. So to those who are joining us for the first time, when we speak about R in maths, we are speaking about common ratio. And we have a formula to get the common ratio. What is that formula? It says T2 divided by T1.
T2 over T1.
T1. And then to those who don't know, let me show you. This is how you get your what? Your T1, your T2, and T3. You go there and you write T1 with a pencil on top. And then this one, it will be T2 for you not to make a mistake. And then that will be your T3, right? So since here we are required to find the common ratio, we're going to use that formula that says R is equals to T2 over T1. When I'm saying R is equals to T2 over T1, I'm actually saying the second term divided by the first term. And then, yes. Any question? Okay, let's do that. What is our T2?
It's 3/100.
So you'll write 3/100. 3/100, guys. And then that is divided by. So math says I must not have many division signs. So this is what we are going to do. Ne? Since our second term is 3/100, to everyone who's joining us for the first time, I'm going to write 3/100. And then we are also having divide by. So you're going to say divide by, you write divide by. And then what is our first term?
3/10.
Then you say 3/10. So to make your work to be much easy, you can punch everything on the calculator. Or those people who don't like to use a calculator like myself, this is how you're going to calculate it. You'll start by writing 3/100. You are not going to be wrong even if you punch it on the calculator. Ne? And then math says when you have a division sign, guys, you introduce a multiplication sign. Ne? Then you do the reciprocal. Reciprocal, you swap them. It simply means to say 10, it will go up. The denominator will become the numerator, and then the numerator will become what? The denominator. So you swap them. That will be what? That will be 10 over what? Over 3. And then again, when you arrive here, math says that you do what? Let's mute ourselves. Please, let's mute ourselves. I will appreciate if we mute ourselves because we are disturbing each other. Let's mute ourselves. So you'll say equals to, then from here, you'll say 3 cancel 3. And then you'll be left with 10 over 100. And then what is 10 over 100? That's 1 over 10. So get 1 over 10. You must get 1 over 10. So here we'll get 1 over 10. So I believe that if you actually punched 3 over 100 divided by 3 over 10, there was no need of you making a lot of these steps. I was just showing you that you must get 1 over 10. If you're pressing it on the calculator, are you gonna get 1 over 10?
Sir,
Yes,
cancel
sir.
the zeros.
Yeah?
Cancel the
Yes,
zeros.
sir.
Yes, the correct answer is it's 1 over 0. So there's someone who's saying something I didn't understand. Who was that? What are you saying?
It was me.
Yes,
I
yes.
was saying cancel the zeros.
Yeah, it's also cool. You can cancel the zeros. 0 cancel 0. Then you're left with 1 over 10. That's good. Then now let's continue to find our sum to infinity formula. So always when they ask you a question about sum to infinity, you must always think about A, which represents the first term, as well as R. So the main important aspect of me showing you R is because of it's needed on the sum to infinity formula. Then what is the formula for sum to infinity? It says that it's A, which is the first term, divided by 1 minus R. Remember, R is the common ratio. Then you say sum to infinity, guys, it's equals to, what is A? A is represented by the first term, which is T1. We can see that you are having what? You are having 3 over 10.
3 over 10.
Yes. And then you can also write divide by. You are not going to be wrong, but it's just that math doesn't want us to have many division signs. But you might as well say divide by, then that will be 1 minus, what is the common ratio? 1 over 10. And then now you calculate your sum to infinity. You will say sum to infinity, it's equals to, when you are saying 3 over 10 divided by 1 minus 1 over 10, what do you get? 1/3, which is going to be 1 over 3. So you can punch everything in the calculator to make your work to be much easy and neat. So it simply means to say, when they say calculate sum to infinity for this question, we are going to get what? 1/3, which is 1 over 3. And then, to those who are joining us who don't know how to get sum to infinity, it's a matter of you understanding this formula. So it will already, you must know this by heart because there are questions in maths that will require you to know how to use sum to infinity formula. Any question?
No, sir.
No question. So if there's no question, then now we are proceeding. So it simply means to say, with regards to sequences and series, we are done, right? I want you to get used to this. There are some questions that has to do with, I saw them where they say, they ask you about determine the values of R for which the series it will converge or it will diverge. Who has ever seen something like that? If I may ask.
I once saw something like that.
Who's speaking to me?
Leceo.
Leceo, yeah. There is something like that. So that one is an advanced question. It's very easy as well. But do you know why I don't want to teach it now? It's very easy. I can teach you at any time. It's very easy. It's because of, I want you to get used to all the formulas that we use, how to use arithmetic sequences, how to use geometric sequences, how to use sum to infinity formula. Whenever you have mastered everything of those, then we go back, we deal with that last part whereby they say, determine the values of R for which the series converge or diverge. Then I know that you will get a distinction. So it's just that I don't want to bombard you with a lot of information for now. I want you guys to get used to how we deal with this, because there are some people who did metric long time ago. So I want you guys to do what? To master this. So to those who are, please guys, don't move the screen. There is someone who's reducing my screen. I don't know who's that. Please don't press anything. I will appreciate that, because you are disturbing me. Ne? So as I was saying,
Sorry, sir.
yeah. So as I was saying, arithmetic is just a revision. But those ones who joined us just now, everything is there on the YouTube channel. So when you speak, it's just a recap of this. Ne? Today we are closing this chapter. There's another one who's reducing my screen again. Yo, guys, please let's cooperate, because you are disturbing me and the video is recorded. Let's not move the screen, please. If you don't see the screen, talk to me, then we'll wait for you to adjust the screen, then we'll continue. So arithmetic series, the general term of arithmetic series is given by Tn. It's equals to, now I'm just giving you a recap, because we're closing this. Arithmetic sequence is Tn is equals to A plus n minus 1d. So you must know this formula. They will say this is an n term or the general term. Ne? Cool. And then with regards to this, always your T1 is always going to be equals to A, which represent what you call the first term. So you must know that first term. Apologies for my handwriting, it's a bit ugly. So that is first term. And then you will also get D. So when you speak about D, we are speaking about the common difference. To those who don't know, common difference. So how do you get the common difference? You get it by just saying the second term, subtracting the first term, or you just say the third term, which is given by T3, you minus the second term, which is T2, just like that. And then one thing that you need to understand after knowing that n, you all know that, what does n represent, guys?
Number of terms.
Number of terms. That's good. Number of terms. Number of terms, number of terms, number of terms. So if you don't know, it's a recap. It represents number of terms. And then we also have the formula that calculates the sum of the number of terms of an arithmetic sequence. It's just the recap. Sn is equals to, that is going to be n over 2, open bracket, a plus, open bracket, n minus 1d. So that is the first formula that you can use. If you're not going to use that formula, which formula are you going to use? You're going to use this formula that says Sn is equals to, that will be n over 2, open bracket, then you'll say a, then you'll say a plus Tn. Some textbook, when they don't say a plus Tn, they say Sn is equals to n over 2. Okay, let me write it here so that you can be able to remember it. So some formula, they use this one. It's one and the same thing. Sn is equals to n over 2. Open bracket, they say a plus l. Something like that. But you must remember that this is one and the same thing. Right? That is it for arithmetic sequences. And then, with regards to geometric sequences, you have already taught this. Again, all the videos geometric that are there, if you didn't understand, or if you're joining us for the first time. Geometric sequence. As much as I might be teaching you, it's your duty again to go back and watch those videos every now and then so that you can understand. Ne? Geometric sequence, the nth term that represents all the geometric sequence, it's what? It's Tn. It's equals to a multiplied by r to the exponent of n minus 1. And then Tn simply represents the nth term or the general term. And then a represents the first term, r represents the common ratio, n represents the number of terms, right? And then the difference between arithmetic sequences, the one that I was just teaching you above here, this one, arithmetic, is that arithmetic sequence has the common difference. whereby you subtract second term minus the first term, or you subtract third term minus the second term. But in another insight, when you look at geometric sequence, it doesn't have the common difference. This one, it has R, which we call it what? Common ratio. Common ratio. So R is common ratio to everyone who didn't know. And then Angry arithmetic sequence, we just say second term minus the first term, which is D. Geometric sequence, it has R being common ratio. And here we don't subtract, we divide. You just say second term divided by the first term, just like that. Ne? So that's how it is. And then the formula to determine the sum of the number of terms of a what? Of a geometric sequence, there are two formulas. The first one, gonna be a bit slow. It's Sn. It's equals to what? A, open bracket, R to the exponent of n minus 1. Yes.
Can you please move the screen up? I can't see anymore.
Are you able to see now?
No. Let me try to adjust it then.
Okay.
I think it's my phone that has a problem. You can continue.
Okay. Yeah. So that's what I was saying, guys. So as I was saying, the formula to determine the sum of the number of terms of a geometric sequence, we're having two formulas. So that is going to be Sn is equals to A, open bracket, R to the exponent of n minus 1, right? And then you divide by R minus 1. So one thing that is very important, this one, you only use it when R that represent the common ratio is what? It's always bigger than 1. So if your R is bigger than 1 or R is greater than 1, you use this formula. Ne? And then how do you get R? You just say second term divided by the first term, just like that. It simply means to say if you can calculate your common ratio, and when you check, let's say your common ratio is 3, they say find the number of terms of a geometric sequence, you're going to use this one. You know why? It's because of you got R being 3, of which 3 is bigger than 1, then you use this formula. And then the second one, you use it when R is less than 1. R is less than 1, we simply means to say R is smaller than 1. What is that formula? That formula is Sn, it's equals to what? A, open bracket, this one is 1 minus R to the exponent of n, close bracket, divide by 1 minus R. Guys, these things, they're not difficult. They just need you to go there and do the work. So if you don't understand, please go back to video number 1 that I've uploaded, video number 2, up until video number 6. I'm still going to upload those. And then if you can take it from video 1, lesson 2, lesson 3, lesson 4, you'll understand them, because the way I teach maths, I won't give you something that I never taught. So if I teach you level 1 question, then when I'm done, I'm going to go to level 2. When I'm done, we continue level 3. That's how normally I teach maths. So you must not be surprised when you see learners getting distinction. You might as well get yourself a distinction if you go back and watch those videos. That's how I teach. I don't jump at. Ne? So this one, you use it when R is less than 1. Do you see? So these two formulas, they're not very difficult. It's a matter of you locating to check. Is R bigger than 1? If R is bigger than 1, you use that one, the green formula there. And then if R is less than 1, you use this one. So with regards to R being bigger than 1, you know that it can be 3, it can be 2, it can be 5, it doesn't matter. But when I'm saying R is less than 1, it's a typical question whereby maybe after saying second term, divide by first term, let's say your R is 1/3. So in this case, 1/3, it's less than 1. Another instance, let's say for an example, after getting the ratio, you are getting 1/2. Such answers like that, then it means to say you use this formula, right? And then after that one, we are having a formula that I recently taught today, which is what? Which is sum to infinity. So that formula, it says sum to infinity, it's equals to A divided by 1 minus the common ratio being represented by R. So someone is saying, say, so we use it when calculating the number of terms. you use it to calculate not the number of terms, but you use it to calculate the sum of the number of terms. It's a good question. So you use that formula to, let me write it here, to calculate what? The sum, not the number of terms, but the what? The sum. The sum means summation. Sum of n terms. N terms. So when I'm saying sum of n terms, you must not be confused. N represent the number of terms, just like that. So that's how basically we conclude sequences and series. If you still struggle with sequences and series, I'm here to assist you guys, but I will encourage you to go to YouTube. The reason why I'm uploading those videos on YouTube is because of I know that if I've explained something, then you don't understand. If you go back there, you revisit it, then you'll still remember it. Ne? Any question, guys?
No, sir.
No question.
No questions.
Yeah. So that's how we conclude the summary of arithmetic sequences as well as geometric sequences. So to those who recently joined us today, feel free to ask questions. I'm someone normally, I feel comfortable whenever I'm teaching you, disturb me on the session. As in like, if you don't understand, you say, I don't understand. Then I feel comfortable like that. Don't leave me going, explaining something whilst you don't understand. Ne? Even if you are new, feel free to stop me at any time and say, sir, I don't understand. So someone is saying, sir, please, when you are done with this example, can you please explain the sigma notation with infinity? Didn't I explain that? Sigma notation with infinity. Actually, I have, I think I never also explained that one. Okay, it's a matter of me going, there is this book that I use. I don't know where I placed it. It has more example with that, but I'm gonna explain it, don't worry. Ne? It's only that one as well as that question that has to do with the formulas of what? Of converging and diverging. Ne? So that's how basically we conclude that. And then, since now you understand, all of you, let me see. Are you all fine with sequences and series? We are proceeding just now.
Yes.
Yes, sir.
Okay. So since now you are all fine, then we are moving to a different topic. Ne? We are moving to a different topic. So those ones who recently joined us today, don't feel as if you are lost. I know these things, it takes time, but at the end of the day, if you are practicing, then you'll know this. Ne? So let's move to the second topic. So this one, it's a topic that will help you to understand what? To understand functions. So I'm just gonna. So how about I say Sn is equal to n over 2 into 2a plus n minus 1d? Will I be wrong for the series? Okay, someone is asking me a question. So how about I say Sn is equal to n over 2 into 2a plus n minus 1d? No, you are not gonna be wrong. Actually, I've explained that. You are not gonna be wrong, stably. Ne? So let's move to this topic. In class, they don't teach it because it only depends on who's teaching you maths. So in maths, there is a topic called logarithms. Logarithms. Who has ever heard of this topic?
Me, sir.
Okay, cool. So there is a topic called logarithms. So if you didn't understand sequences and series, please go to YouTube, watch those videos, guys. Ne? And there are some questions which I didn't cover there and there for sequences and series. Those are questions which are advanced. But for now, I've explained everything from lesson 1 to lesson number 7 on the YouTube channel. So if you are joining us for the first time in closing, make sure that you watch all those videos, then you'll be at the safe pace. So now let's deal with this one. So this topic that has to do with logarithms. It needs you to know basics of exponents. So for you to master this topic, it's one and the same thing with you mastering exponents. Because do you know why it's very important for you to know logarithms? Back in the days, you know these people who came with maths, the likes of Pythagoras, Archimedes, Newton, Euclid, all those great all those great scientists as well as mathematicians, those people back in the days, 1800, 1700, there were no calculators. So how did they calculate maths or do maths? They were using these logarithms. So back in the days, there were no calculators. So this topic, it helps you to calculate without using a calculator. So back in the days when there were no calculators, they were using logarithms. And one thing that you need to understand is that under logarithms, we are having a general equation that speaks about logarithms. So that general equation, it simply means to say that is a what? That is a definition that best defines all. Let me write it, definition. That best defines all the what? All the laws associated with this. And then someone can say, sir, myself, when I was doing grade 12, I was never taught logarithms. Do you know why I'm teaching you? Number one, it will appear in an exam. And the way you're going to get it, logarithms, you'll get it under functions. Because in functions, there are exponential functions. And then one thing that you need to understand in grade 12, somewhere, somehow, they will ask you to draw the inverse of an exponential graph. And one thing that you need to understand is that the inverse of an exponential graph, it's a log graph or a logarithmic graph. So if you don't understand what is a logarithm, then you will be lost. That's why I'm teaching you this. So that definition of logarithms, it says that y, it's always equals to what? Log ax. So you'll get this in the textbook. Don't worry, we are going to connect again. Don't worry. In the textbook, there is a formula called y is equals to log ax under logarithms. If you want more information about this, you can choose any maths textbook and go under logarithms. You'll get to understand what I'm teaching you. And I'm going to be slow as I can so that you can understand. So one thing that you need to understand is that a definition of a logarithm, it says that y is equals to log ax. And then since this is written in y is equals to log ax, I'm telling you, or I told you that logarithms, they go hand in hand with what? They go hand in hand with exponent. So me writing y is equals to log ax, this definition it's written in a what? In a logarithmic form. It's written in a logarithmic form, number one. And then, since this is written in a logarithmic form, we can change it and also write this in an exponent form. So when you're going to write y is equals to log ax in an exponent form, it will be what? It will be x. It's equals to a to the exponent of y. So me writing x is equals to a to the exponent of y, I've wrote y is equals to log ax in a what? In an exponential form. Exponential form. I'm going to answer you 𝗟𝗵𝗋 just now. Exponential form. So you must understand that it's very important. I'm going to answer you 𝗟𝗵𝗋. You must understand that it's very important to know logarithm as well as exponential form. Because if I'm not going to teach these basics, most of you will be struggling when we are dealing with functions. Because an inverse of an exponential function, it's a log graph or a logarithmic graph. And it's there, it's part and parcel of a grade 12 syllabus. That's why I'm starting you here, because I'm preparing you to go and master functions. Now let me go to 𝗟𝗵𝗋's comment. 𝗟𝗵𝗋 ati, A is the base and X answer. Y exponent right? I'm lost. Okay, let me explain this. You are not lost. It's going to be X is equals to A to the exponent of Y. You know why? Let me take you back to this. I normally like teaching this. I normally like to say, whenever you are having A to the exponent of M, we learned about this in grade 8. We learned about this in grade 9. To those who who don't remember this, let me try to take you back. So when I'm speaking about A is always going to be what we call the base. If they say the base, write the base, it's an A there. And then this M, we call it a what? We call it an exponent. Exponent or index. Exponent, please. Exponent. Apologies for my handwriting. It's exponent or index. Ne? And then, when I'm including 𝗟𝗵𝗋 and the rest of the crew, A and M, or A to the exponent of M, we call it a what? A power. Do you see? We call it a power. So it simply means to say y is equals to log ax. It's a logarithmic form. And then you writing y is equals to log ax, changing it in an exponential form, it will be x to the x is equals to a to the exponent of y, whereby a represent the base, y represent the exponent or the index, just like that. So in grade 12, they will say, draw a log graph. Before you can draw a log graph, you must understand that a log graph is the inverse of an exponential function. That's why I'm showing you to understand y is equal to log ax in a logarithmic form. And then I'm showing you how to change y is equal to log ax in a logarithmic form, changing it to an exponential form. You change y is equals to log ax to be x is equals to a to the power of y. It means to say it will be in an exponential form. And then you must understand that, okay, let me write it here again. Because there are conditions. Angry, now you know that y is equals to log ax. It's log ax. It's a what? It's written in a what? It's written in a logarithmic form. Angry, y is equals to log ax. Y is equals to log ax. Then you writing it in an exponent form. It's x is equals to a to the power of y. There's someone speaking? Any question? And then this happens under this condition. You must understand that always a, in this case, it must always be greater than 0. Please write this. There's no way your base being represented by a, it can be 0. A must always be greater than 0. And then, comma, a again, it should certify this restriction. A should not be equals to 1. That's another thing. Ne? Whereby also x is an element of real numbers. Let me teach you maths. I'm going to take you back to lower grades. So when I'm saying x is an element of R, this R in maths, please write it so that you can remember. It means real numbers. Real numbers. So in maths, guys, we are having, okay, just a second. Let me finish writing this. In maths, guys, we are having what you call real numbers, natural numbers, whole numbers, integers, etc., etc. So when I'm including real numbers, I'm talking about what? I'm talking about all negative values as well as all positive values. So don't get confused. It's one and the same thing with me saying x is an element of from negative infinity up until positive infinity. You know why? Me saying x is an element of real numbers. Real numbers is all negative values as well as all positive values. So for us to say y is equals to log ax in a logarithmic form, it's equals to what? X is equals to a to the exponent of y. It only happens under only this condition. So it is this condition. You must never miss this. So this only happens under this condition. There's no way they can say a is going to be equals to 1. I'm teaching you maths. There's no way. If you can get an instance whereby they wrote a is equals to 1, you must understand that that examiner doesn't know maths. Ne? And then, any question? Any question, guys? Feel free to ask. We are still here, don't worry. And again,
No, sir.
if you don't understand logarithms, the grade 12s that I taught last year, I uploaded videos about logarithms again on my YouTube. Please find time to go on the YouTube channel. Please find time. It's a slipping of a tongue. Please find time to go on the YouTube channel. Check again videos of logarithms. They are there. Ne? So you won't even struggle. And then one thing that you need to understand is that we are having laws of logarithms. Now you understand the definition of a logarithm. Then we are having what we call laws of logarithms. If you don't know, let me teach you. And we all know that we are having laws of sets, laws of exponents. We are also having laws of logarithms. Laws of logarithms. So this is one of the smallest topics that you'll ever find in maths. That's why I'm teaching it. Ne? And then under laws of logarithms, we are always having law number one. If this one is not visible, let me use white. So we are having law number one. So law number one of logarithms, what does it say? It says that the log of a base xy base xy, sorry for that, it's always going to be equals to what? To log a x plus log, please write it down, a y. This is not difficult. So if you go to my previous YouTube channels for logarithms, I've actually proved the law number one. I've actually proved all those laws. And then if you can watch them, you'll better understand this when I'm teaching you. So I'm saying go there so that you can watch it so that you don't start again. So now we are just left with some few seconds. The meeting will end now, but we're going to continue from here. It won't be erased. Don't worry. We're going to continue from here. Ne? We're going to continue from here. Any question, guys? And thanks for everyone who's joining us. Feel free to ask questions. We're going to continue. I'm going to send new meeting details on our WhatsApp group. Any question?
No, sir.
Any question?